Hello, I'm pleased to present our research titled Leveraging Generative AI for Context-Aware Refinement in Speech-to-Text Transcriptions. This is a joint collaboration between West Pomeranian University of Technology and the University of Szczecin. Let's dive in. Automatic speech recognition, or ASR, has become essential in many fields, from business to medicine and accessibility. However, even advanced systems still struggle with background noise, speaker diversity, and natural disfluencies. Our research focuses on improving transcription reliability under such challenging conditions. Our main goal was to integrate generative AI into the transcription pipeline. This edition helps refine raw transcripts by improving punctuation, fixing misrecognized words, and enhancing readability, all while maintaining the original intent of the speaker. We propose a novel three-stage transcription process, show its benefits across noisy and distorted audio, and evaluate its impact using both objective ratings and human judgment. The results show promising improvements. A typical transcription pipeline involves two steps, capturing speech and transcribing it using ASR. But these systems face challenges with unfamiliar accents, background noise, and technical vocabulary, leading to inaccuracies that degrade the usefulness of transcripts. One specific problem is homophones, words that sound the same but have different meanings. For example,
the bear was bare, but he still managed to bare his teeth in a frightening manner.
Here, bear and bear sound similar, but have different spelling and meaning. ASR systems often can't disambiguate these from context. That's where generative models come in. Our approach introduces a third step, generative AI-based post-processing. We pass the initial ASR transcript through a language model, prompting it to clean up errors, add punctuation, and ensure contextual consistency. This diagram shows our pipeline. Speech is recorded, transcribed by an ASR system, and then passed to a generative model, and in this case, GPT, which performs final refinements before outputting the improved text. We used a minimalistic targeted prompt to avoid overcorrections or hallucinations. The instruction was to only change clearly incorrect words, improve coherence slightly, and add punctuation. The prompt was deliberately conservative. Changes should only be made where improvements are absolutely certain. This design helps maintain trust in the model's output and limits unexpected substitutions. We created 224 unique samples using both AI and human voices. Variations included increased speech speed, background noise like crowds and trains, audio distortions, and inserted disfluencies like and repeated phrases.
This sentence cleverly plays on the words.
Each speaker read a complex phrase full of homophones. The sentence tested whether the AI can correctly interpret context and resolve meaning.
Homophones can be quite the bear trap for the unwary writer.
For instance, the bear was bare, but he still managed to bare his teeth in a frightening manner.
The sentence clearly plays on the word
BEAR, animal,
BARE, naked,
and BARE, uncover, highlighting the subtle yet significant differences in their meanings.
We use Google Speech Recognition for the baseline transcription and OpenAI's GPT 3.5 Turbo for refinement. All outputs were evaluated manually due to the limitations of automatic comparison tools. Transcripts were scored on a 5-point Likert scale for word accuracy and punctuation. We also flagged whether the AI refined version was subjectively better than the original. Word level accuracy improved slightly, from an average score of -1.254 to -1.049. While modest, this improvement is consistent across different noise levels and speaker types. The most dramatic improvement was in punctuation. Scores jumped from -2.0 to +1.58. This alone significantly boosts readability and understanding, even if word accuracy remains imperfect. As much as 35% of the transcripts was subjectively appraised to be noticeably better after AI refinement. Interestingly, the most noticeable gains came from non-native speakers, where the original ASR struggled most. The presented table breaks down results by challenge type. Under ideal conditions, Google Speech Recognition performed moderately for words, score equals 0, yet there was no punctuation at all, score equals -2. AI improved punctuation to near-perfect levels, and although words didn't need improving, subjectively 57% of samples got improved. When distortion or noise was applied, performance of Google Speech Recognition dropped, and in these cases, AI improved word scores noticeably and consistently improved punctuation. That's not on the slide here, but even when we speed up the speech samples by 25%, the proposed approach still subjectively improved almost 18% of them. AI-generated speech was easier for the ASR to transcribe, so improvements were smaller. But for human, non-native speakers, GPT refinement made a bigger difference, again emphasizing its contextual capabilities. Our experiment highlights how generative AI can effectively resolve homophones. None of the original Google Speech Recognition transcripts got the phrase "bare his teeth" correct. Most were transcribed incorrectly as "bare his teeth," or even stranger alternatives like "wear," "buy," or "spare." After AI refinement, nearly half, about 43%, were corrected to the right phrase. That's a big leap. However, some errors still remained, and in a few cases the model introduced unrelated words like sink or biting. This shows that while generative AI is powerful in using context, there's still a balance to strike between correcting and not hallucinating. One of the clearest wins was cleaning up hesitations and repetitions. The generative model successfully removed disfluencies in 74% of samples, making the text smoother and more professional. Our approach doesn't require retraining ASR models. It's lightweight, flexible, and works well even in noisy environments. It's particularly strong in fixing punctuation and interpreting tricky phrases. However, there are trade-offs. Real-time transcription is difficult because the model needs full sentences to work effectively, and sometimes it introduces hallucinations, changes not grounded in the original speech. Future efforts include adapting this method for near real-time scenarios by using sentence prediction. The prompt should be re-engineered to reduce hallucinations. Also, further testing in multilingual contexts should be executed. Thank you very much for your attention. If you'd like to learn more about what we do, feel free to scan this QR code and visit our website mcda.it.